Did you do probability at all in middle school? Maybe a little bit. Okay. So first we're just going to go over a couple of examples. Okay, so sometimes you're going to have to do probability with a length. So right here you have a line segment, okay, with different line segments inside of it. When this is examples, the sample space. I know that got cut off, so we're just going to write that. This is sample. Okay, so the sample space is going to be all of the possibilities. So for this one, all of the possibilities are all of the points on that segment AD. Then there's going to be some kind of event. Okay, the event is going to change based on what you have. So one event could be all of the points on BC. Okay, and then the probability would be all the points on BC over AD. Okay, so for the second one, it could be an angle measure. The sample space is all the points in the circle because that's all of the possibilities. And then you're going to pick some event, okay, where that's going to be all the points in the shaded region. So then you would find the measure of the angle over the total circle, which is 360. This will be in the area, all points in the rectangle. And then if your event is all points in the triangle, you're going to do the area of the triangle over the area of the rectangle. So in general, when you're finding the probability, that's going to equal your favorable outcome, okay, or your event divided by the total possible outcomes. And then, Caitlin, what were you going to ask?
For the event line, what you're trying to find?
Yes, yep, so the event is just going to change based on what the question is. Yep. Okay, so this is what we want to keep in mind as we start to tackle these problems. So example 1, we're using the length to find geometric probability. So a point is chosen randomly on PS. And then it says find the probability of each event. Okay, so I'm going to use my highlighter. And if a point is chosen randomly on PS, it can be anywhere from P to S. Okay, so that's what we would call our total outcomes. Okay, and then if it's chosen randomly, it says find the probability of each event. Our first event is the point is on RS. Okay, so here's RS. So what we're going to do is we're going to do the length of RS over the length of PS. Okay, so for our event, the probability is going to be the length of RS over the length of PS. Okay, so Brandon, what's the length of RS? 5. Baron, what's the length of PS? Okay, how'd you get that? Okay, yeah, so 7 plus 13 is 20. 20 plus 5 is going to be... is going to be 25. Okay, and then, so if you just want to write below that that's 7 plus 13 plus 5, so you know where that came from, you can do that. Now, what you want to do is you always want to reduce. So if you have 5 over 25, Sam, what number goes into both of those? 5, right? So if I divide 5 by 5, I get 1. 25 divided by 5 is 5. So then your probability is 1/5. So that what that means is you have a 1 out of 5 chance, or a 1/5 chance of choosing a point on RS if you're choosing any random place on that segment. Okay, now this one says the point is not on QR. Okay, a point that is not on QR. So there's actually a couple different ways that you can do this. Whenever you're trying to find something that it's not, one way you can do it is find a point that is on QR. Okay, so we're going to do that first. Okay, so if it is on QR, Logan, what's the length of QR? 13. Okay, and then the length of the entire segment is still what? 25. Now, do you guys know what is the highest number that you can have in probability? Is what? It is 1, and that's because 1 represents what? 100%, right? Okay, so the probability, the highest you can have is 1 because that represents 100%. Okay, remember how you would write a percent as a decimal? You always move the decimal back 2 places. That's the same thing with 100. If you move it back, it'll be 1. So this is the probability that the point is on QR. To find the probability that it's not, is going to be 1 minus 13 over 25. Okay, so again, remember, 1 represents 100%. Okay, so when you have percents, you can just change them into their decimal counterpart. So for 100%, that would change to 1. So if I'm going to do 1 minus 13 over 25, we want to get a common denominator. What's going to be the common denominator with 13 25ths? 25, right? Okay, so what would the top be? How do you rewrite 1 as a fraction with 25 on the bottom? Yeah, 25 over 25. Because isn't 25 divided by 25 1? Yep. Okay, so what this is called the complement. Okay, so one good reason why you would do this is so that you could just do the 13 over 25 because that's something that you can see right away. So then you're just subtracting it from 1. This is really useful if you're trying to find the probability of something that has a lot of possibilities because you wouldn't want to add them all together if you have 100 different possibilities. Right? But what's another way that you could do this one? You can add, say it again?
7 and 5.
Okay, and why 7 and 5? Okay, so then the 2 segments that are not QR are PQ and RS. And so you could put those lengths over PS. So you'd have 7 plus 5 over 25. Okay, now on one like this, really either one is going to be pretty quick for you. Like I said, if there's more options, you're going to want to use the complement. Okay, so if it's not on QR, you can always do 1 minus that value. Okay, and now we're going to go to our next example. So we're using angle measures to find geometric probability. Okay, and they tell you what color each one is. So I'm just gonna color that one in, is yellow. Now, an entire circle is how many degrees? 360. So I have the blue, the green, and the red. So if I want to find what I have in the yellow, what is that going to be? How are we going to find it? Okay, yep, you can add them all up, subtract from 360. I don't have a red highlighter, so I'll just use my pink one. Okay, and this is my green portion. Okay, so let's add these up. What's 108 plus 52? 160, right? Because 2 plus 8 is 110. 110 plus 50 is 160. What's 160 plus 60? 220, right? Okay, because 40 of it is going to go to make the 200, 220. So how much more would I need to get to 360? So 360 minus 220 be 140. So the yellow is going to be 140 degrees. Or you can put it right in. All right, so we're going to use a spinner to find the probability of each event. And the first one is the pointer is landing on yellow. So your probability, which we're going to call P, is going to be the event over the total. Okay, so it's going to be the yellow over the total. So what did we just find were our degrees for yellow? 140. The total is 360. And then, of course, we want to reduce. Now, what you should notice is that you can divide each of these by what right away? 10, which would make it 14 over 36. Now, what goes into 14 and 36 that we know? We know 2 because they're both what? Even. So half of 14 is 7. What's half of 36? 18. If you aren't sure of that right away, just do half of 30 and half of 6 and then add them together. So half of 30 is what? 15. Half of 6 is 3. 15 plus 3, 18. Okay, so then the probability for that is going to be 7/18. Okay, now this is B, so we're still using the same pointer, and it says the pointer lands on blue or red. Okay, if it lands on blue or red, it can be either one. So our probability is going to be the probability that it lands on blue plus the probability that it lands on red over the total. Okay, so again, the total is 360. Okay, and then Maddie Harris, what was our blue percentage? 52. Okay, and then Ethan, what was our red percentage? 60. Okay, so 52 plus 60 is going to be what? 112 over 360. Okay, so again, when you're reducing this, why don't you reduce it by things that you know go into it? Like, what do we know goes into this? 2, because they're both even, right? What's half of 360? What's half of a circle? 180. Okay, so half of 360 is 180. What's half of 112? So what's half of 100? 50. What's half of 12? 6. So put them together. What do you got? 56. Okay, what do I know goes into both of those? 2. Let's cut it in half again, right? Half of 180 is 90. Half of 56. What's half of 50? 25. Half of 6 is 25 plus 3 is 28. You want to cut it in half again? What's half of 90? 45. What's half of 28? 14. Okay, so I know 2 doesn't go into this. So what else goes into 14? 7. So is 7 going to go into 45 evenly? No. 7 times 5 will be 35, right? Right? And then we know 14 won't go in there because why? If 2 doesn't go into 45, then 14 won't go into 45. Okay? Because it's another even number. Alright, so your final answer for this is going to be 14/45. Okay, now the next one says the pointer not landing on green. Okay, so the pointer not landing on green. Okay, so we're going to do it with the complement. Let's do the probability of it does land on green. So one way you might see it written is you'll see probability lands on green. So what is our green space? How many degrees is our green space? 108. Over 360. Okay, so the probability that it does not land on green is just going to be 1 minus 108 over 360. And whatever 1 is, you just find the denominator, which is 360, and it's just 360 minus 108. Okay, so when I think of this too, if I'm doing this with mental math, I try to add up. So if you do 108, right, to get to a whole number, I have to have what? How much would I add to 108 to get to the next whole number? 2, right? So I know I'm going to have a 2 in it, right? So then I'm at 110. So then I would do 210, 310, which is 200 degrees. And then to get from 2 to 310 to 360, I'd add what? Yeah. I want to make sure you're make sure you're exercising those mental math strategies.
Just write it out like 360 over 100.
What's that?
Just write 360 over 100.
Yeah, yeah. I know. Okay, so we still have to reduce this.
How'd you get the 252?
So I just subtracted the 360 minus the 108. So see how they have the common denominator? Yeah. Yep. So if you do 360 minus 108, right, you can borrow. Okay, now we have to reduce. Okay, so if we have 252 over 360, we can divide by 10, okay, because this does not end in a 0. Do you guys want to go the half route, or do you want to try to find a bigger factor? Okay, let's try 4. Okay, so what's 252 divided by 4? 63, okay. And 360 divided by 4 is going to be what? 90. Okay, let's see if there's something else that goes into it. What do you know goes into 90? 3, what else? 9 times 10, right? Okay, does 9 go into 63?
Yes.
How many times? Okay, so then let's divide both by 9. Okay, so 63 divided by 9 is 7. 90 divided by 9 is 10. And then we know that's going to be the lowest, so it'll be 7 out of 10. What would that be as a percentage? 70%. Okay, so the probability of not landing on green, 70%. Okay, so now what we're going to do is use the area to find geometric probability. So we're going to find the probability that a point chosen randomly inside the rectangle is in each shape. And then we're going to round it to the nearest hundredth. Okay, so notice that it says a point is chosen randomly inside the rectangle. Okay, so the entire shape, every single point, is inside that rectangle. So what we're going to set up for the probability is going to be the area of the circle over the area of the rectangle. Okay, so let's find the area of the circle. Usually when they do a circle, they'll do a circle with a dot in it to show the center. Okay, so Baron, what's the area of a circle? Pi r squared. Okay, so here's our circle, right? Jared, what's our radius going to be of this circle? 9, because you have to do what with it? You have to divide it by 2, right? So the radius is going to be 9 here. So the area is going to be pi 9 squared. And 81, what's 9 squared going to be? 81, so it'll be 81 pi. Okay, and we're going to keep that for now. So that's the area of your circle. Okay, now we're going to find the area of the rectangle. Ella, how are we going to do that? Good, and for this one it's what?
50 times 28.
Good, so your area of your rectangle is length times width. So this will be 50 times 28. Okay, and Tina, did you already do that calculation?
1,100.
Yep. Okay, so that's going to be 1,400. Okay, and these are both going to be in feet squared. Okay, so you have 1,400 feet squared. This is 81 pi feet squared. Okay, so then to do the probability, we're going to have 81 pi divided by 1,400. Okay, and then we are going to do this on our calculator because it says to round to the nearest hundredth. Okay, so whenever you're using pi, make sure you're using the pi button. Okay, so I'm going to show you how to do it on my scientific calculator. So I have 81 times pi divided by 1,400. Okay, and I have 0.181. All you have to look at is that 1, which lets you know you're going to keep that as 0.18. So this is the probability. Now, what does that represent? Yeah, as a percent. Yep, so this represents 18%. That means you have an 18% chance, okay, that if you were finding the area of the circle, you would, you have an 18% chance of being on the circle. Okay, what if we did the square? Let's do that one. So let's do B. so if you do either of the two squares, what's the area of one square?
100.
Good. So 10 squared, which would be 100 feet squared. Okay, now because it's two of them, what do?
Multiply by 2.
We multiply by 2. So it would be 200 feet squared. Now the total is still going to be 1,400. But look, now we can simplify this, right? Because you could divide both of them by 100, right? So if you divide them both by 100, you get 2 over 14, which would be 1 over 7, and then it says to round to the nearest hundredth. So how would I do that? You just have to divide, right? So 1/7 would be 0.14. Okay, so this would be a 14% chance. All right, and then your homework is the 9.6 packet.